video, I'm going to talk about how to sketch graphs of the reciprocal function of f of x, that is 1 over f of x. So when we try to sketch the function 1 over f of x, first we can sketch the function f of x first. Based on the graph of the function f of x, then we can convert to the reciprocal function, that is 1 over f of x. But when we convert the function from f of x into the reciprocal function, we must consider some of the important points. First thing is we must consider some of the critical points. First, if the function f of x consists of any maximum point with the maximum value is y equals a, when convert to the reciprocal function 1 over f of x, this maximum point becomes minimum point, but the value of the minimum point is 1 over a. And similarly, if the function f of x consists of any minimum point with the value of minimum is y equals a, when convert into the reciprocal function, this minimum point will become a maximum point, but the value of the maximum becomes 1 over a. Then beside that, if the function f of x has got any x-intercept with x equals b, then when converted to the reciprocal function 1 over f of x, this x-intercept will become the vertical asymptote with the same value x equals b. And similarly, for the vertical asymptote of the function f of x, when converted to 1 over f of x, this value x equals b will become the x-intercept of the function 1 over f of x. Next, for the y-intercept of this function f of x, y equals c, when converted to the reciprocal function, this y-intercept is still y-intercept, but the value of c becomes value of 1 over c. Other than the critical points, if the reciprocal function has got any vertical asymptote, so next we must double check what is the value of y for all the points near to the asymptote. Let's say the asymptote is x equals b here, so we must double check what is the value of y when x slightly less than b, and also when the x is slightly greater than b. So when x is slightly less than b, we use the notation b negative to represent the value of x, which is slightly less than b, and b positive to represent the value of x, which is slightly greater than b. Okay, so now first, when x is slightly less than b, okay, if the value of y is slightly less than 0, so if the value is slightly less than 0, we use this notation 0 negative to represent the value which is slightly less than 0, 0 positive, which means that the value is slightly greater than 0. Now, when x is slightly less than the vertical asymptote, now if y is slightly less than 0, so when converted into the reciprocal function, the x value is still the same. Now only the y value will change from slightly less than 0 becomes negative infinity, because we know that when come to reciprocal function, the original value 0, when come to reciprocal function, we will do 1 divided by the number which is slightly less than 0. So when 1 divided by a very small value, then we will get a very big value. And because this small value is likely less than 0, and which is a negative value, so this infinity becomes a negative infinity. And if the y is a very small value but slightly greater than 0, when converted to 1 over fx, this y becomes a positive infinity, because 1 over a very small number, and this is a positive value, then we will get a very big number. This is a positive value, so that's why we get a positive infinity. So similarly, when x is slightly greater than the vertical asymptote, when y is slightly less than 0, when converted to reciprocal function, y becomes a negative infinity. When y is slightly greater than 0, when converted to reciprocal function, then the value of y becomes a positive infinity. Next, we need to consider what is the value of y when x is infinity. Either x is positive infinity or negative infinity. So when x is either positive infinity or negative infinity, when y is positive infinity, when converted to reciprocal function, this value of y will become a value which is likely greater than 0, because we know that 1 divided by a very big number, so we will get a very small number approximate to 0. And if the very big number is a positive value, then the small number is slightly greater than 0. If the very big number is a negative value, so the 0 will slightly less than 0. So means positive infinity when converted to 1 over fx will get a value which is slightly greater than 0. Negative infinity when converted to the reciprocal value, then value of y will becomes a value which is slightly less than 0. Same as when x approaches to negative infinity. So we need to double check the change of the values of y. Now we are going to sketch the reciprocal function 1 over square root of x plus 2. And 1 over square root of x plus 2, we know that we are not able to use the transformation method. So first, to sketch this graph, first I'm going to sketch the graph square root of x plus 2. To sketch the graph square root of x plus 2, we can use the transformation method that we have already learned. So after sketching the graph square root of x plus 2, so this is the graph. So to convert, the graph becomes 1 over square root of 2. So we are going to consider the sum of the important part. First one is the critical point. So from this square root of x plus 2, notice that this graph has got no maximum point or minimum point. Then we go to x-intercept. For square root x plus 2, the x-intercept is negative 2. So when converted to the reciprocal function, this x equals negative 2 becomes the vertical asymptote. Then for the y-intercept, so for y-intercept, the y-intercept is square root of 2. When converted to the reciprocal function, it is still y-intercept, but the value of the y-intercept becomes 1 over square root of 2. Then after that, since this reciprocal function has got vertical asymptote, so we must consider what is the value of y for the point which is slightly less than negative 2 and slightly greater than negative 2. So now for the x slightly less than negative 2. For the x slightly less than negative 2, we find that for square root x plus 2, x slightly less than 2 is undefined. So means for the value of x slightly less than 2 for the reciprocal function, so also undefined. Then for the value of x which is slightly greater than negative 2, so we can see that the value of y is slightly greater than 0. So when x is slightly greater than the vertical value, y is slightly greater than 0. So when we convert it to the reciprocal function, y becomes positive infinity. So means when x slightly greater than negative 2, y approaches to positive infinity. So after the point which is near to the asymptote, now we consider the point which is at the infinity. So for the square root of x plus 2, when x is negative infinity, so that is undefined. So we don't have to consider this part. Now for x which is positive infinity, we can see that y is positive infinity too. So when x positive infinity, y positive infinity, when converted to reciprocal function, y becomes slightly greater than 0. So when converted to the reciprocal function, the value of y becomes slightly greater than 0. So we can see that the value of y change from positive infinity, go through 1 over square root of 2, then continue to the value of y which is slightly greater than 0. So now, finally, this is the graph of the reciprocal function 1 over square root of x plus 2. Next, we are going to try to sketch this 1 over x power 2 minus x minus 6. Now, first thing, I'm going to sketch this quadratic function. To sketch this quadratic function, first, I'm going to factorize. From the factor, now I can see that the shape of the quadratic function is an U shape. And now, since this quadratic function has got a minimum point, so now I'm going to find the value of the minimum value. So for the x value is the midpoint between negative 2 and 3. So midpoint between negative 2 and 3 is 3 plus negative 2 plus over 2, that is 1 over 2. And the value of y, we simply substitute this value of x into this equation. Now we get the y value is negative 25 over 4. Then followed by the y-intercept. Y-intercept is when x is equal to 0, y is negative 6. Now based on this quadratic function, I'm going to convert to the reciprocal function 1 over x power 2 minus x minus 6. So first thing, that is the critical point I need to consider. So since this quadratic function has got a minimum point, and the minimum value is negative 25 over 4. Now, based on the table just now, we can see that the minimum point for the function fx when converted to the reciprocal function, that minimum point becomes a maximum point, but the value is 1 over a. So now, this minimum point becomes a maximum point, but this minimum value, negative 25 over 4, becomes 1 over 25 over 4. So 1 over 25 over 4, that is 4 over 25. So the value of x is still the same. And since this one is the minimum point, so this one will become maximum point after converted to the reciprocal function. So we use a small curve here to indicate that and to remind us that this point is a maximum point. Then after that, we try the next critical point, that is the x-intercept. Here you have two x-intercept. So the x-intercept, when converted to reciprocal function, that will becomes the vertical asymptote. So we have two vertical asymptotes since we have two x-intercept. Now, next critical point is the y-intercept. So y-intercept is -6. When converted to the reciprocal function, y-intercept is still y-intercept, but the value of y-intercept is 1/6, negative value. So -6 becomes -1/6. That is this point. So since this one is the maximum point, so the graph will go through here. Now, after the critical point, we are going to consider the point which is near to the asymptote. So now, since we have two asymptotes, we are going to consider one by one. So for this part, I'm going to consider what is the value of y when x slightly greater than -2. So now we go back to the graph of f of x. So when x slightly greater than -2, we find that y is slightly less than 0. So slightly less than 0 means we'll change to reciprocal function. Y will go to -infinity. So for this side, so the value of y will go to -infinity. Now we can see that the shape of the curve will slightly go here. So we need to double check what is the value of y when the x slightly less than 3. So when x slightly less than 3, y is slightly less than 0. So means when converted to reciprocal function, so the value of y also becomes -infinity. So we can see the shape of the curve here. So when we combine all this value of y, so the shape of the curve at this region is like this. So now we are going to look at this region which is less than 2. So when x is slightly less than 2, and we can see that y is slightly greater than 0. So when y is slightly greater than 0, when convert into the reciprocal function, y becomes positive infinity. Now we are going to consider when x is negative infinity. So when we look at here, when x negative infinity, y is positive infinity. So when x negative infinity, y positive infinity, then will becomes y slightly greater than 0. So now here, y slightly greater than 0. So we can see the change of value of y, that is from positive infinity slightly changed to slightly positive. Then for this side, now when x is slightly greater than 3, before changes, y is slightly greater than 0. So when changed to reciprocal function, y become positive infinity. So now for the x approaches positive infinity, y is positive infinity. So x positive infinity, y positive infinity, when converted to reciprocal function, becomes y greater than 0. So now the value of y will be here. So now when we combine the value of y, so the graph will be like this. So now finally this is the graph of the reciprocal function 1 over x power 2 minus x minus 6. Next, we are going to try this one. 1 over x power 2 minus 2 plus 3. So first I'm going to sketch this quadratic. But we find that this quadratic we are not able to factorize. If the quadratic is not able to be factorized, so we are going to use completing the square. So after completing the square, we will get something like this. So based on this form, now I'm going to sketch the quadratic function. Now based on this completing the square, this is the value of x at the minimum point, and this is the value of y of minimum point. So for the y-intercept, when x is equal to 0, y-intercept is 3. So now I'm going to convert to the reciprocal function. First, because this quadratic has got minimum point, so minimum point when converted to reciprocal function will becomes maximum, but the value of y becomes 1 over 2. So value of x is still the same. So the point 1, 2 will become point 1, 1 over 2. And minimum becomes maximum. We use a small curve here to indicate that this point is a maximum point. So next, this graph has got no x-intercept, so means the reciprocal function has no vertical asymptote. Then for y-intercept is 3. When converted to reciprocal function, it is still y-intercept, but the value of y-intercept becomes 1 over 3. Now, then next, we consider the infinity. When x approaches negative infinity, y positive infinity. So when y positive infinity, when converted to reciprocal function, the value of y is approaches slightly greater than 0. When x approaches positive infinity, y is positive infinity. So value of y positive infinity when converted to the reciprocal function, the value of y is slightly greater than 0. So now we can see the shape of the curve. Now we combine all the information. Now we will get the shape of the graph of this reciprocal function. Now for this function, 1 over ln x minus 2. So first I'm going to sketch the graph ln x minus 2. So the graph for ln x minus 2 is something like this. Now based on this graph, I'm going to sketch the reciprocal function. So first, since this ln has no maximum point or minimum point, then we look at the x-intercept. So the x-intercept becomes the vertical asymptote of the reciprocal function. Then for any vertical asymptote, after change to reciprocal function will becomes x-intercept. So since here we have a vertical asymptote, when changed to the reciprocal function, that point becomes x-intercept. But because of the function is ln x minus 2, we know that x will never equal to 2. Because when x is equal to 2, the function is undefined. So means this one is the value of x but never equal to 2. So now, since this graph has no y-intercept, so we continue. Now for the vertical asymptote, so we have to know what is the value of y which is near to the asymptote. So now we consider this part first. For the x slightly greater than 3, before convert x slightly greater than 3, y is positive 0. That is a very small value of 0 but positive. So when convert to reciprocal function, the value of y becomes positive infinity. Then when x is positive infinity, y is positive infinity. So when y positive infinity converted to the reciprocal function, the value of y becomes 0 but slightly positive side. So now when we combine all the value of y, then this curve is like this. Then for the value of y which is from 2 to 3, now we consider the value of x which is slightly less than 3. So when x slightly less than 3, the value of y is slightly less than 0. So when slightly less than 0 converted to the reciprocal function, y is negative infinity. So now for this vertical asymptote, when the vertical asymptote is x is 2, when converted to the reciprocal function, the value of x still the same. But because of this x value will never be equal to 2, so now the curve will continue up to here, but not included 2. So now generally this is the shape of this reciprocal function. Now we are going to sketch this graph 1 over modulus x minus 2. So first I'm going to sketch the graph modulus x minus 2. So the graph of modulus x minus 2 is this one. So now based on this graph, I'm going to convert to the reciprocal function. So first thing, we need to consider maximum point, minimum point. From this graph, even though this point seems like minimum point, but actually this point is the x-intercept. So any x-intercept point, when converted to the reciprocal function, this point becomes vertical asymptote. So after that, for the y-intercept 2, when converted to reciprocal function, it is still y-intercept, but the value of y-intercept becomes 1 over 2. Next, since the reciprocal function has got vertical asymptote, we need to consider the value of y that is near to the asymptote. Okay, first we consider on the right hand side. When x is slightly greater than 2, y is slightly greater than 0, that is 0 positive. So 0 positive when converted to reciprocal, that is positive infinity. Then for this side, when x is positive infinity, y is positive infinity. So y positive infinity converted to the reciprocal function becomes slightly greater than 0. So when we combine all the value of y, this is the curve for this quadrant. Then next, for the value of y which is slightly less than 2. So when x slightly less than 2, y is slightly greater than 0, that is 0 positive. 0 positive converted to reciprocal becomes positive infinity. Then followed by when x is negative infinity, y is positive infinity. So when y positive infinity converted to reciprocal, so the value of y becomes slightly greater than 0. So when we combine all the value of y, so this is the curve at this quadrant. So generally this is the graph of the function. So I think that's all for now. I hope that this video can give you some guides on how to sketch the reciprocal functions. And if you find that this video is beneficial, please share to your friends. And if you have any question, you're welcome to Teacher Eileen Maths Group, and you can forward any question that you have in the group and we try to help you. So, thanks a lot.